Have you ever stopped to think about all the stuff around you? The air you're breathing, the water you drink, the phone in your hand? Well, it turns out we can classify literally all of it into just a few basic categories. And understanding those categories is key to understanding, well, pretty much everything. So let's dive right in.
So let's kick things off with the big question. What exactly is a pure substance? It sounds super simple, right? But nailing this definition is the foundation for everything else we're going to talk about.
The answer really boils down to one word: consistency. See, when a scientist talks about something being pure, they don't mean it's, good for you or organic. They mean it's the exact same thing all the way down to the microscopic level.
And here's the official definition. A pure substance is made up of only one kind of particle. That's it. One single type of building block repeated over and over. Think of it like a giant bin full of nothing but identical red Lego bricks. If every single piece is the same, you've got a pure substance.
Now, even within this pure category, things get interesting. It actually splits into two main types: elements and compounds. Both are totally pure, but they're constructed in very different ways. First up, we have elements. These are the true fundamental building blocks of the universe. An element is made of only one type of atom. A bar of pure gold, it's just gold atoms, and that's all. The key thing is, you can't break an element down into anything simpler by chemical means. They are the absolute basics on the periodic table.
And then you have compounds. This is what you get when different elements decide to team up and form something new. A compound is made of two or more elements that are chemically bonded together in a very specific, fixed recipe. That fixed recipe part is absolutely crucial. Water is always H2O, two hydrogens, one oxygen. That chemical bond creates a whole new substance with its own unique properties, completely different from the original elements.
Okay, so we've got the super orderly world of pure substances down. But what happens when things are just thrown together without any of those serious chemical bonds? Well, that's when things get a little messy, and we enter the world of mixtures.
And a mixture is pretty much what it sounds like. It's when you take a couple of different substances and just physically mix them. They're all hanging out in the same container, but they haven't chemically reacted. There are no new bonds forming. They're just roommates, not a married couple.
And because of that, all mixtures have three things in common. First, no new substance is actually created. Salt mixed in water is still just salt and water. Second, you can take them apart again using physical means, like filtering or evaporating. And third, there's no fixed recipe. You can have really salty water or just slightly salty water. It's still a mixture.
And just like with pure substances, mixtures also come in two main flavors. It all depends on how well everything is mixed together. We call them homogeneous and heterogeneous.
A homogeneous mixture is blended so perfectly that it looks like one single, uniform substance. You can't see the individual parts. Once you dissolve salt in water, it just looks like water, right? The air you're breathing right now is another perfect example. It's a mix of nitrogen, oxygen, and other gases, but it all looks like one clear, invisible thing.
And on the complete opposite end, you have heterogeneous mixtures. Here, the components are not evenly mixed, and you can totally see the different parts. The classic example is oil and water. No matter how much you shake it, they separate. Or think about sand and water. You can see every single grain of sand at the bottom. It's chunky, it's uneven, it's heterogeneous.
All right, this brings us to the main event, the big showdown: mixture versus compound. Honestly, if you can get the difference between these two, you've mastered one of the most important ideas in all of chemistry. So let's put them head to head.
This chart breaks it all down. For combination, a mixture is just physical, while a compound is a full-on chemical bond. For the ratio, a mixture can have any ratio you want, but a compound has a strict fixed recipe. To separate them, you can use physical methods for a mixture, but you need a chemical reaction to break a compound. And maybe the biggest difference? In a mixture, everything keeps its own properties, but in a compound, you create a brand new substance with totally new properties.
Okay, let's zoom in on a special type of mixture that we deal with constantly: solutions. A solution is really just the scientific name for a homogeneous mixture. They're everywhere.
And every solution has two parts. You've got the solute. That's the stuff that gets dissolved, like sugar. And you have the solvent. That's the stuff that does the dissolving, like the water in your tea. Usually the solvent is whatever you have more of. Simple as that.
We can even get a little more specific based on how big the solute particles are. In a true solution, like salt water, the particles are so tiny they're invisible.
In a suspension, like sandy water, the particles are big enough to see and they'll eventually settle to the bottom. And then there's the weird middle ground, colloids, like milk or fog, where the particles are just floating around, suspended, but they don't settle out.
So, if mixtures are just physically jumbled together, that means we should be able to physically pull them apart, right? Absolutely. And the methods we use to do that are called separation techniques. They're super important in labs and in industry.
Here are a few of the most common ones. You've got filtration. Think of a coffee filter touching the grounds. There's evaporation, which is how you get sea salt by boiling away the water. Distillation is a clever way to separate liquids that boil at different temperatures. And then you have more advanced stuff like chromatography for separating colors and centrifugation, which spins things really fast to separate them by density. That's how we get cream from milk.
Phew. Okay, that was a lot. So let's wrap it up with the 4 biggest takeaways. 1. Elements and compounds are the 2 types of pure substances. 2. Mixtures can be either homogeneous, where they're perfectly mixed, or heterogeneous, where they're not. 3. Solutions are just a fancy name for homogeneous mixtures. And 4, the big one. You can separate mixtures physically, but you need a chemical reaction to break apart compounds.
So, next time you stir sugar into your coffee, make a salad dressing, or just breathe the air, you'll know exactly what's going on at a chemical level. Now that you can classify the world around you, what mixture will you look at differently? If this helped you, like, share, and subscribe for more smart learning.